Hello one and all. Today I'm telling about the topic graph databases for knowledge management. Myself KV Jayakumar. I'm from mechanical engineering. Introduction to graph databases. The graph databases are designed to represent and store data in graph structures. They utilize nodes, edges, and properties to facilitate complex relationships. The structure allows for efficient surveying and data relevant in knowledge management systems. These graph databases they are designed to represent and store data in graph structures because they utilize nodes and edges like and properties to facilitate complex relationships. The structures allows for and retrieval knowledge management for systems. Key concepts of graph databases. Nodes represent entities such as people, places, or concepts. Edges define the relationships between nodes enriching the data context. Properties are attributes of nodes, edges, and allowing for data representation. Nodes represent into such as like concepts like places or concepts and people. Edges define the relation between nodes and enriching the data context. Next, knowledge worker and document. Here the picture about the knowledge worker and document and expertise. Name is equal to string, department is equal to string name, D is equal to description and data types. Properties are attributes, nodes, and edges, allowing for detailed representation. Data created date, data updated date, and is equal to. It just define the relationships between nodes enriching the data context. Next, benefits for knowledge management. Graph databases enable the modeling of complex relationships within the knowledge. The graph model supply chain, career, statement, shipment, history, industry, products, product, career, delivery, customer. Next, they support flexible schema designs accommodating evolving data needs. The means they not to know academic dates evolving data needs. Enhanced connectivity facilitates better insights and faster decision making. So graph databases enable the modeling of complex relations within the knowledge. They support flexible designs and accommodating evolving data needs. Because enhanced connectivity facilitates better insights and faster decision making. Another use cases in knowledge management. Graph databases can be used for semantic search, improving information retrieval. Therefore, customer, order, product and index includes product, places order and includes product. They support recommendation systems by analyzing relations between users and content. They support the only recommendation and systems by the analyzing relations between the users and content. Knowledge graphs can be built to visualize and navigate organizational knowledge. The knowledge can be built by the only visualize and navigation of the locations to the organizational knowledge. Next, comparison with relational databases. Unlike relation databases, graph database access in handling interconnected data. Unlike relational databases and graph databases are excels in user in the interconnected data. They avoid the performance and pitfalls of joint operations by using direct relationships. These are two allies and allies into three types belongs to A4 future A42 labels relationships. This leads to more efficient squares and required to complexity in data management. Therefore, nodes into the allies into percent into labels into department, future AP1 A42 belongs to that. This leads to more efficient queries and reduce complexity in data management. Next, popular graph databases solutions. Neo is widely recognized for its robust graph processing capabilities, and Amazon Neptune offers a fully managed graph and database service in the cloud. Arrange ODP combines graph, document, and key value data models for flexibility. Amazon Neptune offers a fully managed graph database in the service in the cloud. And here the example of the database solutions. The create and the matrix and titles of the matrix releases DAX likes is widely recognized for its robust graph processing capabilities. The Neptune should offer a fully managed graph database service in the cloud into the graph document and key value that models for flexibility. Should manage the linked systems. Next slide. Integration with existing systems. Graph databases can be integrated with traditional databases using ETL processes, APIs, and connectors enhance interoperability with other software tools. This generation supports a seamless transition into a graph-based architecture. Here the example of the attributes of classes: physical entry, catalyzed activity, regulation, reaction. The all conform the model stored in a graph: physical entry registration, physical entry, catalyst activity, label reaction, stoichiometry and relationship property. This integration supports a seamless transition into a graph-based architecture. Here the architecture problems and display string and catalyst activity, physical entity, regulation, output, input, and something where catalyst activity and stored. This is the stored and display name of the physical entity: regulator, regulability, catalyst active, physical entity, output, and input. Input is equal to physical entity and output equal to, as usual, in physical entity. The databases and can be integrated with the traditional databases using ETL processes. ETL process can be used in another tools and softwares, interoperability and APIs and connectors to the other software tools. Graph databases and the ETL processes are used in some seamless transition into a graph-based architecture. These are some architectures on a end-to-end transition and the graph-based architectures. This integration supports a seamless transition into a graph-based architecture. Graph bases can be integrated with traditional databases and using ETL processes and connectors enhance interoperability with other software tools. This integration supports a seamless transition into a graph-based architecture. And end-to-end connectors enhance interoperability with other software tools and the graph-based architectures into a transition. This integration supports as a transition on the meals into a graph-based architecture. Some discipline names and strings and stoichiometry and physical entity regularity cattle activities, physical entity input and output. IPS connectors enhance with interoperability with other software tools, graph databases, and the integrated with the traditional databases using ETL process. And next one, challenges and considerations. Data migration from traditional databases can be complex and time consuming. The ultimate guidelines is to data migration, challenge strategies, and considerations. The ensuring data quality and consistency is critical graph databases. Organizations must evaluate the skills required for managing graph database technologies. And we know that data migration from traditional databases can be complex and time consuming. The data quality and consistency is critical in graph databases. Organizations must evaluate the skills required for managing graph database technologies. This is the time consuming and ensuring data quality and consistency in critical in graph databases. Organizations must evaluate the skills required for managing graph database. Future trends in graph databases. The adoption of AI and machine learning will enhance graph databases capabilities. Here we now to see the picture. Artificial intelligence adoption and investment rate. Adoption rate all 13%, 13, 15, 25 year. In the year of 2019, the adoption rate is 13%. Year of 2020 is 30%. In 2021, 15%. In 2022, 25%. In 2023, 18%. The investment rate is equal to in 2019, 24%. 2020, 27%. 2021, 29%. 2022, 39%. 2023, 28%. Include this all the artificial intelligence adoptions and investment rate and trend. Increased focus on real-time data processing will drive advancements in graph technology. Graph databases are likely to become more prevalent in enterprise level knowledge management because the AI machine learning will engraph graph database capabilities. Here, here the increased focus on the real-time database processing will drive an advance in graph technologies. Last in conclusion, the graph databases provides a powerful solution for manage complex knowledge structures. They are able to represent relationships, make them ideal for various applications. Embracing graph databases can lead to improved knowledge discovery and utilization. Their ability to present relationships makes them ideal for various applications. Embracing graph databases can lead to improved knowledge discovery and utilization. The graph database are efficient to respect local data analysis. Locality is defined direct different structures. Frame all solutions to problems as traveler over local regions of the graph. And the locality is defined by direct different structures. This is graph transfer. And embracing graph databases can lead to improved knowledge discovery and utilizations. Their ability